Okay, well, okay, so my talk's about Civo security best practices. Now, this isn't going to be your everyday security best practices. This is my best practices because I have quite a unique perspective of Kubernetes. It's probably different from your average DevOps or programmer, given what I do. So let's go to the. I need to learn how to control this thing. There you go. Wonderful. Right. So my name's Jahred Love. I am CTO of Cersus, which is a turn server company providing services to WebRTC applications developers and applications themselves. CTO of what we call Freemio, which is a file room platform for commercial real estate, which isn't live at the minute, so no one look that up. It's down for various reasons, and we'll be up again soon. And I'm also lead WebRTC engineer at Aircool, which is a global telephony application for desktop and mobile. So I do a lot of stuff. I've been programming commercially for about 22 years, but programming personally since I was 9, 1985. So a long time. Most of my career has been based around R&D stuff. I like to do sort of cutting edge technologies, whatever they are. I mean, I'm like the Rosetta Stone of languages, not spoken programming. So I do a lot, and so working with Kubernetes, I'm not a DevOps. For me, that's a little bit sort of scary. It's a little bit too rigid. I like to have more interests in that, but I do a lot of DevOps work anyway because I find it interesting. Okay, so. Kubernetes is a framework. So we've moved on a lot from how things used to be in my early years of development, when everything, you had behemoth applications all running on a single server. Obviously, we've got K8s now, and we're using containerization and deploying applications at scale really easily and what have you. But one of the biggest differences for me is that your infrastructure is now part of your code. If we're breaking down our applications into smaller chunks, smaller moving parts, and they're like bricks of the building. And Kubernetes then and other infrastructure tools become the concrete that fit between those bricks. And you can't really separate one from the other. If you've got a behemoth application and you want to run that on K8s, then that's a really bad idea, and you shouldn't do that because it's not designed on the offset to work with an environment like K8s. Similarly, when you're building an application that is going to run in a microservice environment, not necessarily K8s, but preferably you're going to know it's going to run on K8s from the beginning, you design your application knowing that you're going to make use of certain features in that environment to allow the communication and flexibility of your application, how you expect your service to evolve over time. So because of that, relying on your DevOps to know everything you need them to know is near impossible. There's usually so much information that they need to have, and having one small team or one guy know all of that information is just not practical. Things like, what sort of data your application is going to be sending between service nodes, what sort of data you're giving to the users of your application, and what sort of communications they're going to send to the application. So very often you end up splitting that responsibility between the DevOps and the developers. So you give the developers a small chunk of what they're going to do on K8s, and the DevOps has the rest, making sure, sort of the overseer, making sure you're not doing anything silly, because, we all know programmers do silly things. So there, from the beginning, is a security, potential security issue. Now, with applications development in K8s, a lot of the security tools that we use against a Kubernetes cluster normally looks at the security from the outside in. We scan the vulnerabilities, what can I access, how can I bring a system down, how can I gain access to the system in order to get access to data or access to code, etc. But from a development perspective, a lot of the security implementations that we can create start with the actual development of the application. So you can start thinking about security with your code. When you're actually building your pods and what have you, and writing code that's going to exist in containers, you can figure out how to reduce the likelihood that someone is going to get access to information they shouldn't have, and reduce inter-process communication or sensitive data that is passed in inter-process communications to keep your application secure from both sides. Okay. Now, when you build a Kubernetes cluster, you always need to expect that not everyone who's going to be attacking your system is going to be a hacker. So we all, like to think, or a lot of people like to think of hacking as being, how we see it in the movies. So if anyone's seen the movie Hackers, someone sort of tap away on their keyboard and in 30 seconds they access a government mainframe or something, and everything's graphically visualized, and you can do some really cool stuff that it looks like anyone can do. But a lot of it actually is a lot of dirty work. It's all about having small bits of information that you shouldn't have access to. Hackers I've known in the past would say that, if they wanted to hack someone's network, they're going to pop round to their to the company's place of work, their actual building, and sort of take a dive into their rubbish bin and start searching through pieces of paper with any sensitive information on it that they can use. But not everyone who's hacking your system or violating your application security are going to be that sort of person. There's one story I heard in the news about a guy, and I might get this story wrong, this is about a year or two ago. There was a guy that was downloading information about a court case from a government website. And he found that by changing a numeric value in the URL field, he can look at other court case information he wasn't supposed to have. And he was really interested in court cases and the legal system or what have you. So he wrote a script that just cycled through a range of numbers and downloaded information from court cases, hundreds of court cases. And he ended up having a knock on his door from the police that came to arrest him for hacking a website, hacking the government servers, when what he was doing wasn't really hacking. It was just a use case that the developers hadn't thought of. They hadn't perceived as being an issue. All he was doing was just doing something out of the ordinary, which users do all the time. Everyone, if you build a system that's open to being hacked, it's got to be hacked by people that aren't intending on hacking your system. So that's one of the first rules, is to make sure that you think of every eventuality of how your system's going to be used, not necessarily anticipating someone attacking your system, but someone just being different, someone thinking a little different to yourself, probably. So that brings you to testing your environment, not testing in terms of security, but testing that the data that you're exposing from your Kubernetes cluster is the data you're expecting to be transmitted to and from, and anticipating what users may possibly do. And it's not possible to get every eventuality included, but certainly trying to test other ways of accessing that data, making sure that no data that shouldn't come out of your system is coming out of your system. The next, obviously, is when you're developing your applications, you develop them in a debug mode. So there's every platform has a way of having a debug mode. It could be, it could be providing literal information about line by line of how your code is structured so that you can figure out where problems go wrong when they go wrong. It could be including information that you would normally use in a development environment, but maybe it's gotten into your production environment. It could be not creating an actual final build of your application, which is more efficient than a debug build, or various ways. It might even be running a source code version in production, which is a big no-no. You need to make sure when you deploy your applications within the containers they're full release versions. They're completely clean of any development related configuration or code, and they're as small and efficient as possible, giving nothing away to anyone that were to look at that application from within your pod, if they were to get access to your pod. If you are using a platform which is normally uncompiled code, then any information that it would be easily accessible. For instance, you might be using PHP, which I know PHP can be compiled, but not many people do that. So if you have any sensitive information in there, excuse me, then it needs to be in a format that you would expect someone to be looking at it. You shouldn't be looking at it. You need to be able to think of ways around having that information accessible. If you know someone, you have to anticipate that someone will eventually be able to look at that source at some point. The next point is to understand that nothing is temporary. Nothing should ever get pushed to your production environment that you think, it's only going to be there a short period of time, so it's okay to leave it there for now. You're going to replace it. That should never happen. If you're in that position, you shouldn't push it to production. Even if you've got, you have a deadline, you want to push something out quickly, still take the time to make sure that what you're pushing is production ready, because otherwise you're exacerbating a situation that you already have. You're just sort of, adding fat to the fire, or whatever the saying is. So everything should be 100%. You should be fully certain that what you have is ready to go to production. And finally, don't have features for the sake of it. Now, you know what your application is going to do. Your application should do exactly what you want it to do and no more. So you shouldn't have anything else in your application that is unused as much as possible. Obviously, you're going to include a database or some sort of caching system, etc., that have additional features that you would not normally make use of. That's fine. But in your own code, or in terms of the features, the services that you're going to have within your application, keep them small. This doesn't only reduce the risk that your application can be abused in some way by a hacker, but it also saves money. It makes your application more efficient. It reduces the resources that you're utilizing, and it keeps everything smooth, fast, and slick. It's the difference between having, a sports car versus an articulated lorry, essentially. Excuse me. Right. Now, everything in enterprise is a war. You're going to have malicious people sniffing around your application. You're having a constant battle. There's so many moving parts to an enterprise app that there's always things to keep an eye on, things to track. And one of the easiest ways to sort of lose a war is to give away too much information. As my wife says, this one, loose lips sink ships, is something my wife often likes to say. And she's not trying to protect us from hackers, but it is true. The more information you give away, the more it can be used against you, whatever that might be. So you have to keep it to yourself. And that's it's not just with regards to being careless, sorry, with passwords and security information, but it's also with regards to what people can glean from your setup. If you've got a WordPress application, for instance, don't make it look like a WordPress application. If someone can go to a URL and just type /wp-login, they'll know it's a WordPress application. And then they can say, right, okay, I know a number of vulnerabilities for a WordPress application. I wonder if, if they've updated this recently, I might be able to gain access to this application and bring it down. So if they don't realize it's a WordPress application, if there's nothing on there that enables them to see what it is, then it suddenly astronomically increases the possibilities of what it is and makes it less likely that they're going to be able to target your application and bring it down or gain access to data they shouldn't have. Now, another thing is, obviously, if someone's going to be able to probably figure out something from your application at some point, they're going to be able to figure out what parts make it tick, and they're going to be able to try vulnerabilities they're aware of. Now, when you deploy an application, as much of the information as possible should be unique and should be battle ready. You shouldn't have any default values existing in your application. You shouldn't, if you've got salted passwords, you shouldn't leave the original salt that from whatever open source software you're using there. You should modify it and change it. Laziness is a big vulnerability to hackers. Likewise, not knowing the product. If you don't know the product you're using, there's going to be various avenues that you're unaware of that the hacker are going to know and use that to violate your application. And also keeping abreast of changes in that app. If you need to make sure you stay on top of any new releases, because most releases come out or are made available for open source software because of a security loophole or vulnerability. And you can bet that as soon as a hacker is, as soon as that vulnerability becomes public and the company producing that software has released a new version, there are going to be hackers looking for somewhere where they can use that vulnerability, just for fun. Very often, just to say, haha, I hacked your platform. There are people that do that. So keep abreast of all those changes and implement them ASAP. Right. So, which is, this slide here is basically exactly what I was saying before, giving hackers what they want, telling hackers what software you're using unbattle tested software. So if you've got, not all open source software, for instance, is good open source software. There are a lot of kind-hearted developers producing really interesting stuff without a clue about security or vulnerabilities. And it might seem cool, it might seem like it saves you a lot of work, but you can tell normally if you're looking on GitHub and you're using a tool that only 13 people have starred or something, that it's probably not something that's battle hardened. Likewise, using software that is being forked, if you're using a fork of someone's software, then there may have been changes to that software that make that software suddenly less reliable than the original. So, making sure that you've got something that's tried and tested, that people in the community are informing the developers of any issues, and it's getting updated regularly. You can see on the repo, for instance, when it was last updated. If it's updated a year ago, it's probably not something you want to use. If it's updated 2 days ago, you're more likely to have something that's being actively worked on and improved. Out of date releases. So with regards to using open source software, I tend to build my own images. If I build my own images, I know I'm using the latest master or the latest release. I know that I can put it on Docker Hub for free, and so I can pull that. So if an image I'm using, for instance, from a third party is taken down, that's not going to be an issue if I've pushed my own image. And also, I know exactly where it's come from. And I will also fork the original repo, the GitHub repo. So if that gets pulled, I still got access to it, because there's nothing more frustrating than having your software built around someone else's code. And everyone builds their software around someone else's code nowadays, even big companies. For that software to get taken down and no longer have access to it, you don't want to be stuck. So forking that software at every step and having full control of that software is the only way to ensure that you are releasing what you know to be safe and making sure it's always there in the future, and you're not going to have an application that suddenly becomes useless and you can't update anymore. Default configuration settings I've already covered, making sure that you've not got anything left that is default in the configuration, or misconfiguration, which is not knowing what the configuration really is doing and configuring it incorrectly through ignorance, essentially. Know your software, know what it does, know someone else's software as well as your own if you're going to use it in your cluster. Right, flapping features. So this goes back to keeping everything tight and slimline. If you've got an unclean and messy environment, then it can be your undoing. It really can. A lot of what we build in Kubernetes is about having small parts that do a specific task, and you don't want too much overlap or too many features that are going unused that can be abused by someone who's aware of it being there, and you've left it in because you're lazy, or because you weren't applying due diligence. If you are updating your application and you're deploying a new pod, and that pod has different configuration to the previous one, you need to make sure you clean up after the previous one. The same with services, the same with every single aspect of your Kubernetes environment. Keep on top of all of the configuration of the containers and every layer there that without that container, and ensure that all of the different elements within those configurations are still in use, still specific. And there's nothing that will allow, there's nothing that might conflict with what else you're deploying and what you've built. When you're deploying, don't just deploy and think that's it. You need to follow up on a daily basis, keeping an eye on your application, keeping an eye on the logs. You need to see, has the use of your application changed over time? Is there anything that people are doing that that doesn't seem right? If you're seeing, for instance, in the logs that there's a lot of authentication failures, and that's a red flag, someone's trying to gain access in some way. Very often, if someone is trying to access through authentication into your platform, they know something, and so they're trying out some stuff. They're aware that there's possibly a security flaw in your application, and so they're trying to leverage that essentially. So your logs are your friend there. And as I said, always clean up constantly. Always, you're going to be spending a lot of time writing code. You need to be spending just as much time ensuring that your cluster is super tight. Right, protect your etcd. Am I the only one who calls this etc.d? Is that just me? It might just be a thing. So this is the heart of your application. This is the heart of your cluster. Now, with etc.d, you need to make sure that the read access of your etc.d provides visibility, or the etc.d provides read access of all of your configurations and settings for your secrets for your cluster. If someone outside of your team or your company, some malicious third party has write access, then they can manipulate your cluster and they can bring down various elements of your cluster, etc. It's very sensitive part of your cluster. Ideally, you should have TLS communications to encrypt all messages to and from your server messaging. If you've got any visible packets, and obviously those can be leveraged to the detriment of your cluster, so you need to avoid that where possible. Likewise, you need to minimize traffic within your cluster, which is a good thing anyway, because you're reducing resource usage. You should also filter traffic with a firewall. If you keep your etc.d on its own node, away from publicly accessed nodes, and you put a firewall between that and your API, then you're creating another layer to control what sort of traffic is going to your etc.d and how people are gaining access. There's no reason really why anyone should be able to gain access to your etc.d node. Right. Security musts. So damage limitation control. Use role-based access controls. I know Siam mentioned this earlier. Now, role-based access controls use, they restrict who can do what, but the RBAC use is just a secret token, which you can share. So it's not totally secure. If I was to give that token to someone else, and they would have those same accessibility capabilities. So we should also use certificates for multi-factor authentication, which will obviously stop them from accessing the cluster at all if they don't have that certificate. So you need both together to control who can access your cluster and then who can do what within each of the namespaces on your cluster. Now, I believe for RBAC, you have both namespace-based and cluster-wide role configurations. There should be very few people using the cluster-wide. Most of it should be namespacing. So you should use namespacing wherever possible. Obviously, as I said, you need to have allow developers access to your cluster, limit what they can do, and certain elements, including the etcd node, they should never have access to directly. Define your network policies. What sort of data should come in and out of your containers? If you as a DevOps, you should know in advance what sort of data is going to be sent in and out of a cluster and on what ports. So your network policies just ensure that people aren't sending stuff they shouldn't, or trying to find vulnerabilities within your cluster. Node isolation, again, you should isolate your etcd node. Your etcd node should really only be accessible from the master node. You need to limit the number of nodes you have access to the public internet. Most of your nodes won't need a public IP. You should have just a private internal IP on each of your nodes, except the master node. You should utilize access control lists. Consider allowing only master node connections on specific ports using the ACLs to reduce what can be sent and requested from your nodes. Restrict which processes can be used so as to prevent malicious processes from running. So if you imagine someone's gained access to a pod and you don't want them installing stuff that they shouldn't be using. So, if you already will know what processes your software will be using, so you can ensure that those are on the white list and only those can be used. And obviously we have audit logging so that we can see who has done what and what processes are being called and how. So you can monitor just how secure your platform is, or if anyone is trying to gain access when they shouldn't. And finally, secrets. So don't store your secrets in your source repository. That's a big no-no. You should ideally try and use Vault or something similar to manage your secrets. Your secrets can get unwieldy. Don't use the same secrets between each of your environments because you tend to get a bit lax with your development and staging environments, etc. And if you have the same secrets between both, then more people know the production secrets than should or than is advisable. And finally, encrypt your secrets. So secrets are stored in your K8s cluster as base64, which is just it's as good as plain text. But there's no reason why you couldn't further encrypt those into something else and just have your compiled source code, your compiled applications aware of how to convert to and from readable format, rather than having someone just be able to see it at will outside of those pods. And that's it. That's my take on best practices.